Hello and welcome to Math with Mrs. Becker. Today in College Trig, we are going to go ahead and finish up our notes from section 4.3. Yesterday in class, we were able to make it from here to here. We just kind of talked about the basics, the 6 trig ratios and how they pertain to right triangles. So we will go ahead and start right down here. It says, often you will be asked to find trig functions of a given acute angle. Remember, theta will always be an acute angle, meaning less than 90. To do this, construct a right triangle that has theta as one of its angles. So here's an example. Let's just say that they tell you to find the sine of 45, cosine of 45, and tangent of 45. Reminder that 45, 45, 90 is a special right triangle. Now, we are working with triangles now, not the unit circle, so we can't automatically assume that the hypotenuse measurement is 1. So let's go ahead. I'm just going to show you how they're related. Just kind of a cool little thing here. So if I draw a right triangle, if this is 45 degrees, this would also be 45 degrees. Now, because we're not in a unit circle, it doesn't mean that automatically across from the 90, this is a 1. So let's be rebels, and across from the 45, let's make that a 1. Well, if across from here, this is 45. If I go across, that's a 1. Because this is also 45 degrees, that means that this is an isosceles triangle. So across from this 45 would also have to be 1. Well, I know two sides of a right triangle. I can use the Pythagorean theorem. A squared plus B squared equals C squared. A and B are the two legs. The legs are the two sides that create the 90-degree angle. So 1 squared plus 1 squared equals C squared. 1 squared is 1. 1 squared is 1. 1 plus 1 is 2. That equals C squared. In order to cancel the power of 2, you go ahead and take the square root. Remember yesterday, one of the things we talked about is when you are calculating the trig function, they will always be positive. So when you have something like this, yes, I canceled the power of 2, but I'm only including the positive, so this would be square root of 2. Now, if I want to find the sine of a 45-degree angle, let's say this is the angle we're going to use. So across from that 45-degree angle, that's the opposite. Across from the 90, that's the hypotenuse. That makes the third side adjacent. The sine is the opposite over the hypotenuse. You cannot leave it like this because you do need to rationalize the denominator. So this is the square root of 2 over 2. The cosine of 45. The cosine is the adjacent over the hypotenuse. So it's 1 over the square root of 2. Again, we must rationalize the denominator. Square root of 2 over 2. The tangent of 45. Tangent is opposite over adjacent. 1 over 1 is 1. So the cool thing is, because this was a special right triangle, even though we were looking at a triangle and we did not have the hypotenuse as 1, when we went ahead and found the sine, cosine, and tangent, we still ended up with the same values that we would have had on the unit circle. Because on the unit circle, this would have been 45, this would have been 45, this would have been 90. Our ordered pair would have been square root of 2 over 2, square root of 2 over 2. So the sine would have been the y value, that matches. The cosine would have been the x value, that matches. The tangent is y divided by x. Because of the same thing, when you divide them, you get a 1. So yes, we're thinking of it totally different, but they are definitely still related. Now let's look at a 30, 60, 90. This time they did give us measurements. If I want to find the sine of 60, okay? So if I'm going from 60, this is the opposite, this is the hypotenuse, this is the adjacent. So the sine is the opposite over the hypotenuse. Okay, if I want the cosine of 60, the cosine is the adjacent over the hypotenuse. Now they want me to do the sine of 30. So we're totally good. Now I just have to go from 30. So now the opposite is 1. The hypotenuse is still 2. Adjacent is the square root of 3. So the sine of 30 is opposite over hypotenuse. It's 1/2. They want us to find the cosine of 30. Cosine of 30 is the adjacent over the hypotenuse, so square root of 3 over 2. Now again, trig, you're going to notice so many different like relationship type things, okay? So one thing that hopefully you noticed is here, when it was 60, the sine was the square root of 3 over 2 and the cosine was 1/2. When we switched to 30, the two values switched. The sine of 30 was 1/2, which matches the cosine of 60, and the cosine of 30 matched the sine of 60, okay? Same thing happened here. What the relationship is, in trig, you will have their partners, okay? Sine and cosine happen to be partners. Because 90-degree angles are complementary, when you have your partner, so sine and cosine, 45 plus 45, that equals 90. So they would have the same measurement. Here, sine and cosine are partners. 60 plus 30 makes 90. If the angle measurement adds up to 90 and one is a sine and one is a cosine, they're going to have the same value. Really, really cool. Cosine of 60, sine of 60. Cosine and sine are partners. 60 and 30 makes 90. So that's why they both have the same measurement. So when I flip this over, it's just a really cool relationship that you're going to see in this class, okay? So here is what this is saying. So sine and cosine are, they're partners. So as long as their angle measurements add up to 90, they'll have the same value. Tangent is a partner with cotangent. So same thing. The tangent of 45 and the cotangent of 45 are going to be the same thing because 45 plus 45 equals 90. The secant and the cosecant are partners. Okay, so here's a little chart just kind of showing you. This works for 30, 45, and 60 because that's commonly how we can get 90 degrees. If I have the sine of 45 and the cosine of 45, they happen to be the same. The sine of 30 would be the same as the cosine of 60 because 30 and 60 have the same measurement. The cosine of 30 and the sine of 60 would have the same thing. Okay, so let's go ahead and use that relationship and try to figure out some of these things, okay? So the tangent, ooh, they're starting us off kind of rough. Now remember, the tangent is y over x. Now the sine is the y value and the cosine is the x value. So if I want the tangent of 60, I take the sine of 60, which is the square root of 3 over 2, divided by the cosine of 60, which is 1/2. Well, I can't divide fractions. So I keep the top the same, change divide to multiply, flip the second one upside down. The 2's would cross cancel. The square root of 3 over 1 is the square root of 3. Now the sine of 30. Sine and cosine are partners. So for this trick to work, you need one sine and one cosine. So sine and cosine are partners. This is 30, this is 60. That adds up to 90, so they'd have the same measurement. So if the cosine of 60 was 1/2, this is also 1/2. The cosine of 30, that would go with the sine of 60. One is a sine, one is a cosine. 60 and 30 make 90, so they have to have the same measurement. So they are both square root of 3 over 2. Cotangent of 30. Cotangent is a partner with the tangent, and we know that because of right here. This lists out the partners. So these would be the same because tangent and cotangent are partners. 60 and 30 make 90, so if this is the square root of 3, so is this. It's just kind of a really cool relationship. Okay, the next one. Here is another thing. Let's say that this is like, holy crap, what's going on? Okay. Another thing that you can do, and for some reason I always did this, which is why I know it's kind of the long way, because I always do everything the long way. You could take this information. Sines and cosines are typically the easiest to do. So let's say I go ahead and I draw out a right triangle. I know I have a sine of 30, so it's a 30, 60, 90-degree triangle. Sine is the opposite over the hypotenuse. Opposite of 30. So opposite of 30, this would be a 1. Hypotenuse, this would be a 2. Now from here, I could go ahead and figure out what this measurement is using the Pythagorean theorem. Then I could just use the trig ratios. So you can use the relationship like we did here. This one I'm going to go ahead and use a triangle. So if I'm doing Pythagorean theorem, a squared plus b squared equals c squared. 2 would be a c, let's say 1 is an a. So 1 squared plus we don't know b squared equals c squared. Well, this would be 1 plus b squared equals 4. If I minus 1, b squared equals 3. Take the square root, and b is the square root of 3. Okay, so again, now if I want the cosecant of 30, the cosecant is the reciprocal of the sine. We know that the sine is 1 over 2, so I could just go ahead and say it's 2 over 1, which is 2. The cosine of 30, the cosine is the adjacent over the hypotenuse. So the adjacent is the square root of 3 over 2 over the hypotenuse, which is 2. So the same as 2 over 1. I would keep the top the same, change divide to multiply. Then I'd flip this upside down. And so I'd have the square root, here we go. Oh, sorry, this is just the square root of 3. Sorry, my bad. Okay, I saw this 2 right here on the square, and I was starting to do this. I'm like, wait a minute. So the adjacent is the square root of 3. It's over the hypotenuse, which is just a 2. That looks much better. Cotangent of 60. Now, cotangent is the reciprocal of the tangent. Tangent is the opposite over the adjacent. So this is the adjacent over the opposite of 60. Okay, so 60, this is the opposite, this is the adjacent. So it's adjacent over the opposite. Go ahead and get rid of that square root on the bottom. So square root of 3 over 3. Cotangent, again, that's the reciprocal of the tangent. So the tangent is opposite over adjacent. So this is adjacent over opposite, 30. So across from the 30, this is the opposite, this is the adjacent. So this time it's the adjacent over the opposite, which equals the square root of 3. So again, there's 2 ways that you could do this. You could take something like sine or cosine, use it to draw a triangle. Again, then you'd use the Pythagorean theorem to make sure you have all 3 sides. Then you could go ahead and on the front of these notes, here are the side relationships for sine, cosine, tangent, cosecant, secant, and cotangent. So that's always a possibility, okay? If you are comfortable with the whole, you have partners, and if the 2 angles are complementary, meaning that they add up to 90, then they'd have to have the same measurement, you can use that relationship as well. Okay, so both methods are correct. It's just 2 ways to find the answer. And yesterday we did go ahead and do the story problem. So you guys, we just finished 4.3. Hope you enjoyed your time together, our time together today. I'll talk to you soon. Bye.